Okay, Fermat's method of integration. Fermat is interested in measuring the area under curves of the form y equals x to the n. And his method was unique because it used a sum of infinite geometric series, as we will see. Okay, so I made this diagram to kind of show what Fermat was after. All right, he, like most integration techniques, he would take the curve y equals x to the n for a given n, and he would make these rectangles that go to the height of the curve. However, the bases had an interesting formation because this, while this was a given a, because he wants to find the area from the origin to a, this would be at a times r for an r less than 1 and greater than 0. Okay. And so this would be a times r. This point right here would be a times r squared, and the next point would be a times r to the third power, and so on and so on. And this is how he would form his curves. So the area of the curves, to find the area of this rectangle, you would take the base times the height. Well, the base would be a minus a times r, right? Because this is ar, right? So it would be a minus ar, and the height would be a to the n. So to do base times height, we do a times a to the r times a to the n. And to find the area of the next rectangle, he would take a times r minus ar squared, right? And the height would be ar to the n. Okay. And then the next term would be ar squared minus ar to the third, and that would be multiplied by ar squared to the n. And the next one would be ar to the third minus ar to the fourth times ar to the third to the power of n. Okay? So, and it will go on and on and on. So to rewrite this, we can factor out an a here, and we get that a times 1 minus r times a to the n, and then that turns into 1 minus r times a to the n plus 1. Okay. The next rectangle, this would be the area. Factor out an ar, and then we get 1 minus r times ar to the n plus 1. Okay. The next rectangle was ar squared minus ar third. Okay. And the height was ar squared to the n power. So we can factor out an ar squared. So we have 1 minus r, and multiply that times a times r squared over to the power of n. Okay, and that becomes 1 minus r times ar squared to the power of n plus 1. Okay, so these are the areas of our rectangles, and we can sum them up. And when we sum them up, the sum would look like this. And what we can do is factor out the quantity 1 minus r times a to the power of n plus 1, and we get this 1 plus r to the n plus 1 plus r to the power of 2 times n plus 1 plus r to the power of 3 times n plus 1, etc. Okay. And because we know that to sum an infinite geometric series, when t is between 1 and 0, we get 1 plus t squared plus t to the third ad infinitum equals 1 over 1 minus t. So if we replace t with r to the power of n plus 1, then this sum will become 1 over 1 minus r to the power of n plus 1. And of course, this was all multiplied by this, so we're going to bring down the 1 minus r times a to the n plus 1. And now we have this.